All right, let's work through each one of these. So PBr3. So first off, you count up the total number of valence electrons in each atom. So P is in family 5. Bromine is in family 7, but there's 3 of those. So we end up with 26 total valence electrons. So remember that number, 26. I then put the less electronegative one in the middle, or the one I have the least of, which is P. I'm going to put a Br, and a Br. Now remember, phosphorus is one that can expand its octet if you need more. But if you only have 3 total things, it's probably not going to be an issue. Okay, the next step is to complete the octet on each outer atom. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, the next step is to see how I'm doing so far. So far I've assigned 8 times 3, so I've assigned 24 total electrons so far, which means I have 2 left over. The leftovers always go on the central atom. All right, so I put the 2 there, and then I look. By putting those 2, did I satisfy the octet for the central atom? The answer is yes, I did. So this would be the correct Lewis structure. PBr3, you would have this. Okay, hopefully not too bad. Next, N2H2. All right, N has to be the central atom here, because hydrogen can't ever be the central atom. That means it must be bonded to another N. All right, and then we're going to put an H on each side. Okay, now N is in family 5, but there's 2 of them. So there's 10 from here, and there are 2 from hydrogen. It's 1, but there's 2 of them. All right, so I end up with 12. So far I've used 6. I don't need to put more dots on H because you can't. Once it has 2, it's completely full. So I have to complete the octet on the ends. To do that, I need 1, 2, 3, 4, 5, 6, 7, 8. All right, that would be dandy, except for when I do the math now. I have 2, 4, 6, 8, 10, 12, 14. All right, that won't work because I only had 12. So what I'm going to do, I'm going to erase, and I'm going to put a double bond now. All right, now that would make too many on the end. And I look now, I have 2, 4, 6, 8, 10, 12. That's how many I had to start with. And now I'm set. If you put the pairs up here, that would be fine. It doesn't necessarily matter where they are so far. Number 3, CH3OH. Remember, H can never be a central atom, and O is more electronegative, so C is going to be forced here to bond with 3 H's and 1 OH. And then the O must be bonded to another H. That's the only way this structure can work out. All right, so the next step to do, now that there's an H on each one of these, I should have done the math first, I guess. Sorry. Carbon had 4 valence electrons. There are 4 H's, and each one has 1. And there's 1 oxygen, which is 6. So we have 14. So looking over here, I have accounted for 2, 4, 6, 8, 10. I have 4 left, which is perfect, because to complete the octet on this oxygen, I need 4 more. 1, 2, 3, 4. Now, every atom has a full valence shell, and I didn't have to form any double bonds, so it's pretty pumped in life. All right, Now, if your structure is the same but like in a different, like up, the O goes up or left, it doesn't matter as long as it looks something similar to this. Okay, now NO2. N has to be my central atom, and I have to have an O coming off each side. I know that because there's only one of these and two of those. All right, let's do the math. And we do need to notice there's a -1 this time, which means it has one more electron than normal. So nitrogen's in family 5, oxygen's in family 6, but there's 2 of them, so that's 12, plus that one more we gained when we became a negative. So 5 plus 12 plus 1 is 18. All right, so I've put my less central one here. I'm going to complete the octet of the outer ones. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now I am at 16 that I've used so far. I have one more pair. I could put it here in the middle, and that would be equal to 18, but that wouldn't octet nitrogen. So what happens is nitrogen and oxygen form one side that has a double bond. So now I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I need to count in twos, I'm sorry. 2, 4, 6, 8, 10, 12, 14, 16. And then I need another pair on the nitrogen. Okay. That one's a little bit trickier, but it's completely doable and acceptable. And this one, by the way, is the first one that would have a resonance structure. So if you saw something like this and it said, you know, is there a resonance structure present? This one would, because if you had O, double bond N, single bond O, and then all the same dots, this would be the same model, just the double bond in a different place. That's what a resonance structure is. So in NO2 minus 1, or nitrite, if you remember, you could say it has a delocalized pair of electrons. All right, final one, C2H4, C, H, H. All right. All right, this is pretty much your only structure. I had to sneeze for a little bit that would work. So, well, before the video, I don't think I had that double bonded, or before I paused it. All right, so this is how you would connect them originally. All right, and it's the only way that really works. And now each carbon only has 6, so you have to put that double bond in the middle. Some people might think, well, you got a C, and then you got another C, and you have one H over here, and then H, H, and H. All right, that would octet this. We have 2, 4, 6, 8, 10. I never did the math here, did I? Carbon has 4. 2 times 4 is 8, plus 4 more, because there's 1 for each hydrogen. There's 4 of them. That's 12. So to do this, we'd have 2, 4, 6, 8, 10, and then we could put another pair on this carbon, and that would get us 12. But this one won't work. Remember, these are H's. That one doesn't work because we're not octetting this carbon atom fully. So the only way to get it to work is to have that double bond in between. Okay, hopefully that was helpful. If you still need help, there's the 2 videos on Edpuzzle that may help clear things up.